Thank you so much for checking out this tutorial on getting started with RAG and DSPy. I am more excited about DSPy than ever after completing this tutorial. Just the end-to-end of loading in a data set, defining an LLM metric, and then seeing how DSPy can compile or optimize the prompt to achieve better performance is all just super exciting. I think we're walking into the next era of LLM programming with this prompting framework, automatic optimization framework. So I really hope you find value out of this video. It's designed to be a full end-to-end. We're going to load in our data set, and we're going to see how to load each example from our data set into dspy.Example objects. We're going to define an LLM metric, and we're going to write our RAG program using the DSPy programming model and looking at some details like the built-in modules like chain of thought, React, and all that kind of stuff. And then the super exciting thing, we're going to compile, optimize the prompts by bootstrapping few shot examples and using the Bayesian signature optimizer, tweaking the task description. We're going to be using all the good machine learning stuff of train test data splitting to evaluate our new program and all these super exciting things. I really hope this video helps inspire your interest in DSPy. Our uncompiled RAG program is improved by about 30% in this tutorial by using the optimizers, and I think we're just scratching the surface. This tutorial is meant to be kind of like a hello world of DSPy, or maybe more accurately like a CFAR 10 classification tutorial when you're starting with PyTorch. So I hope this end-to-end helps you see how to use DSPy, how to write your programs, and how to optimize them. And then, you know, the sky's the limit with your creativity on where you want to go next with what kind of programs you want to write and optimize. Let's dive into it. Really quickly before diving in, if you're looking for the code that's used in this example, it'll be open source on github.com/weaviate/recipes. This is a group effort with a lot of the colleagues at Weaviate that I'm just beyond lucky to work with. And it contains all sorts of other examples if you're interested in that. But these notebooks particularly will be in /integration/DSPy. So the second thing quickly that I wanted to say in this intro is I'm terribly sorry about the zooming in and out of the last video. Rest assured that there will be zero zooming in this video. So hopefully that makes it a little more readable. And again, I'm really sorry about that. So also really quickly before diving in, I wanted to give some mentions to the DSPy community. First of all, major thank you to Krista Opsalong, who debugged the Bayesian signature optimizer over the weekend. And without her help on this, that I would have been delayed with making this video. So thank you so much. Also thank you to Omar Khattab, Michael Ryan, Carol Dusterling, Arnav Singhvi, and the entire DSPy team. It's such a talented group of people, and I'm just so excited to see DSPy evolve. I also want to quickly give some mentions to some people in the DSPy Discord community who are doing amazing things. First of all, Sean Chapman, he gave a live talk in the DSPy Discord about some updated work on Pydantic and DSPy. Also has a newsletter on LinkedIn and the DSPy GPT guide, which is super cool. Then Thomas Ale, who's created a pull request for Pydantic support with DSPy signatures, which I think I'm not super familiar with how this all works personally, but what I do understand about it from studying instructor and DSPy is that this kind of Pydantic type validation should be a major unlock with this framework. So thank you both so much. It's all super exciting. Then thank you to Knox, who tweeted out a gist on how to use Ollama in DSPy. I think that will warrant its own video on this channel because being able to use the local LLMs with this kind of compilation framework, I think after watching this video, you'll definitely appreciate the value of Ollama and DSPy. So thank you so much. And then Stephen Byron, who's written an article, Why I'm Excited About DSPy. I thought this was really inspiring, so I highly recommend checking that as well. So there will be some links in the description to some people in the community. I highly recommend joining the DSPy Discord, and to everyone in the DSPy community, thank you so much for all the support on the first video and all the conversations as we're all trying to figure out DSPy together. It's definitely, you know, a lot to wrap your head around. So it's so nice to build this community of people who can trade ideas, debugging support, and all that awesome stuff. So thank you so much, and let's dive in. All right, let's dive into it. I'm super excited to share with you this notebook I've created on DSPy end-to-end for compiling a basic retrieve then generate RAG program. This has just been so exciting for me, and I hope this video will help share that excitement and explain the concept a little better. So to kick things off, the idea of DSPy is, I think there are two major things to it. One, the programming model is super fascinating. You have this way of writing LLM programs. You have a lot of default modules like chain of thought, React, all these super interesting things. And there's, you know, some overlap there with the structured output work that's been done. And then you have this compilation or optimization of the prompts used in LLMs, or you could fine tune the models with the synthetic data. But in this example, we're going to be looking at two kinds of optimizations for our RAG, particularly the question answering LLM. So we start off with rewriting the task description and then bootstrapping few shot input output examples to use in the prompt. This is also known as in-context learning. So when we're building RAG programs, we often start our program off with a prompt like, please answer the question based on the following context. And now this is where all that manual prompt tuning starts to come in the picture. Is one way to try to improve this might be to have very important in all capital letters, and then please make sure that the answer is based on the context, exclamation point. So we're trying to, use the prompt space to make sure the model is really following the retrieved context and understanding the task. So the first thing I want to point you to is when we're using this signature optimizer, DSPy is going to rewrite that initial prompt of please answer the question based on the following context into assess the context and answer the given questions that are predominantly about software usage, process optimization, and troubleshooting. Focus on providing accurate information related to tech or software related queries. And you'll see even more interesting examples of how it combines that task description with some input-output examples of, retrieving context, reasoning by using that DSPy.Chain of Thought built-in module, and overall creating this super powerful prompt to serve as our RAG program. So this notebook is going to be a full end-to-end. I'd say it contains 4 parts really, although there's a part 0. We're going to start off with DSPy settings and installation. Then we're going to dive into DSPy datasets and wrapping each example from your dataset into dspy.Example objects. In this tutorial, we're going to be using a retrieval engine that has an index corpus of chunks from the Weaviate blog posts, and we're going to be retrieving those chunks in order to answer the 44 Weaviate FAQs. So the second key part is LLM metrics in DSPy. So this is a super interesting concept where instead of using exact match or maybe keyword overlap scores to assess how the quality of the LLM generated answer, we're going to use another LLM that's going to rate the answer on different dimensions, such as how faithfully grounded in the context it is, how engaging and detailed the answer is, and then just an overall assessment of the quality of the answer. The third thing is LLM programming with DSPy.module and the DSPy signatures. And so we're going to dive into how to write RAG programs, and I'll give a little teaser of the next video where we're going to be doing more advanced RAG programs, just to help you get this concept of how you can add depth to these programs to get more performance. And that's a part of just this super interesting analog of DSPy LLM programming with, say, PyTorch or Keras neural network optimization, is this idea of adding depth and inductive biases by adding more layers to your LLM programs. But that's not really the focus of this video. But the focus of this video is the end-to-end, which brings us to the fourth key part, which is optimization. So again, we're optimizing the examples in the prompt as well as the description of the task. We're going to do this by using DSPy's Bootstrap Few-Shot random search, and the Bayesian signature optimizer. So let's dive in. I think that's everything from the beginning. So setting things up with the maybe less exciting stuff, we're going to be using the DSPy-library, and we're going to be using the 2.1.9 version. Just in case you're unfamiliar with the syntax, this is how you would tell Pip what particular version of the library you want. And in these tutorials, we're going to be using the Weaviate retrieval engine, and it's very important that you're using one of the 3rd versions of the client rather than the 4th version. We'll be updating this soon with the new V4 client, but nothing will change on the side of the DSPy interface. So then we're going to be using the OpenAI models. I wanted to give a quick thank you to Knox on Twitter, who posted this gist of how to connect DSPy to Ollama, and that'll definitely be a future video. This whole idea of using local LLMs, these super powerful Mistral, Llama 2 models, and all these models. It'll be so exciting to keep building on the LLMs we're using in these DSPy tutorials, but for now, we're going to be using the OpenAI model. So all you do is you set the LLM as dspy.openai. Then you set the retrieval engine. In this case, the Weaviate syntax is just you connect whether it's hosted, whether you're locally hosting Weaviate. It could be embedded in the notebook itself, or you could be using the managed service. So we pass in the name of the collection. It's going to assume that you have a default text key called content that's going to be retrieving from. Then you set the DSPy settings with the LM and the retrieval model. So really quickly before going further, this is all you need to basically get set up. But I just quickly wanted to highlight this DSPy.context thing. So when you're setting in the settings, that means DSPy is going to use this language model and this retrieval model as the default throughout the processing. But if you want to say use a different LM or a different retrieval engine, like something I think is really exciting is combining, say, your private vector database like Weaviate with something like one of these web search APIs like the U API or Perplexity. So you can use these this DSPy.context to use multiple retrieval engines and multiple language models. So here's just a quick example of you can access GPT 3.5 Turbo with dspy.settings.lm and then write a 3-line poem about neural networks just to show you that these are indeed 2 different models. So this would be how you would then define another model and then pass another model. Next up is the data set that we're going to be using to optimize our LLM program. So as a quick primer, the Weaviate RM that I connected to DSPy, that's already filled with chunks from Weaviate's blog post. And if you want to see the full tutorial on how to set up Weaviate locally and how to load chunks into the retrieval engine, you can follow this link on Weaviate recipes. So we're going to be using the frequently asked questions from Weaviate's website as the data set of our questions that we want our RAG program to answer. So I have these in a markdown file. This is just parsing out the format of the markdown file and then loading in the questions. So we have questions like, do I need to know about Docker to use Weaviate? And so on. So we have 44 of these questions. So the next thing to know is once you have your data set into DSPy, now you're going to be wrapping each example into a DSPy.Example object. So what this involves is defining the input keys. So in this case, we're just using one input key to kind of, keep the tutorial simple and just sort of get out of the gate. So we're just using question equals question, but you could also say supervise intermediate predictions of your LLM program. Maybe you want to have gold documents that should be retrieved, and maybe you're trying to optimize the prompts of LLMs that go in the retrieval layer of the kind of retrieved and answered system. I think if you're interested in reading more about that, Llama Index has done an amazing job of outlining all these different retrieval strategies. And so you can add supervision to the retrieval part by adding it as one of the keys in the DSPy.Example so that then the metric can access that value as well. So we're doing some standard machine learning stuff, and that's just one part about DSPy I love so much, is that it's bringing us back to these train test split and having all this kind of machine learning thinking in our LLM development. So the first 20 examples are going to be used for training, for tweaking the prompts. We're going to then, come up for air and see how we're doing with the metrics with these 10 examples from 20 to 30 in our development set. And then only when we're absolutely finished with our optimization will we then evaluate on the test set. Okay, so now that we've installed the libraries and loaded in our data sets, it's time to really begin the DSPy party. So we'll start off with LLM Metrics. So first of all, we're going to be keeping it relatively simple in this tutorial, as we're just building a question answering system and assessing the quality of an answer, whether it's based on the context and so on, is a relatively straightforward assessment metric. Whereas you can imagine really long form things you could do with DSPy, like say write an entire blog post, or if you're writing code, you might have a different approach to how you have like programming test metrics. And so hopefully this will kick off the thinking and help you get a sense of this. But I highly recommend checking out this tutorial on DSPy/examples of using LLM metrics to evaluate the quality of LLM generated tweets. So the first thing, again, as we showed with the context, we're going to be using a different LLM for our metric than our LLM that's going to be in the RAG program answering the question. So actually we're going to use GPT-4 as the metric. So the first thing that we're going to be doing in this case is setting up a signature to initialize the prompts for the LLM evaluator. So we begin with the general template, assess the quality of an answer to a question, and then we're going to give it these input fields and our output field. So our input field, the context for answering the question, this is the retrieved documents from the retrieval engine. Then the evaluation criterion, we're going to be changing the evaluation criterion with a prompt for is it detailed, a prompt for is it grounded in the context, and then just overall, how's the answer to this question. Then we're going to be passing in the answer to the question, and then we're going to be using a rating between 1 and 5 and a little bit of that prompt engineering stuff we're trying to get away from, but only output the rating and nothing else. So it is an idea to optimize these metrics as well as a part of the DSPy program, and it's pretty meta. That's a part of what makes all this so exciting, is that the abstractions are open to finally start doing this kind of synthetic data, LLMs, optimizing LLMs, and all this super exciting stuff. But let's keep it maybe a little easy just to connect the program and get started. So then what we do is we're defining our LLM metric. We pass in the gold, which is going to be one of these examples. And so we have the question key. So we get so from our gold, we have the question equals gold.question. Then as we write our DSPy program, we're going to have the prediction, and we're going to have the output key dot answer. So we get the values out this way, and then we're just going to use f strings to first of all just kind of log it for ourselves, and then we're going to put the question and the predicted answer into these prompts, and then we're going to be passing these into the metric LLM. So the first thing to note is we're going to be getting the context again this way. You could put the context in the output of the prediction. So I'm going to be having the prediction from our DSPy program, not to jump ahead too much, but we're just going to be outputting the answer. You could also return the context in the forward pass as the output from the DSPy program. So we're just going to retrieve again, And then we're going to be using DSPy's chain of thought. So DSPy has these built-in modules. If you want to just pass in the prompt as you've written it, you would just use dspy.predict. But dspy.chain of thought has this really interesting way of formatting to come up with a rationale, a reasoning before the final output. And I found this to just be super, super fascinating with watching how it reasons and how that improves the performance, and just a super effective thing you get out of the box with DSPy, which again, I think there are two values to DSPy, the programming model and just being able to, format your prompts, clean up your code bases by writing the prompts in doc strings and then descriptions of the input output fields and how it adheres to the output fields. But then there are these built-in modules like chain of thought or react or program of thought that give you this kind of advanced prompting just right out of the box with no need for you to try to figure out how you're going to parse the outputs, format the prompts, and all that kind of stuff. So we initialize the module with this assess signature, and then we're going to be running a forward pass. So you could also say, do it like, detail module equals this, and then you would, run the forward pass like that, right? But we're just going to be doing it in one line. Okay, so that gives you the three metrics. Then they come out, and then we cast them into floats again. So this is one of the most interesting topics, in my opinion, in all of LLM programming right now, is the kind of pedantic stuff, the work that Jason Liu's doing with Instructor on making sure that it does output a float. But the DSPy compiler, as we'll see later on, if it says, no or yes instead of the rating, the DSPy compiler will just sort of move on, but maybe something to be fixing as we're, say, scaling this and all that kind of stuff. So we're going to be weighting the faithful answer ×2, because in my opinion, with building RAG, that's generally the most important thing you're looking for. And then we'll return the total divided by 5.0. So the maximum score you could receive would be, 5 plus 10 plus 5, 20 divided by 5 is 4. So once you've defined the metric, and quickly I had left an error with the underscore module, but it's fixed now. So let's test our metric and see how it runs. So in this example, we're passing in the question, what do cross encoders do? And then we're testing the LLM metric with an answer of they re-rank documents. So in this case, you get a faithfulness score of 5, which is saying that the context does say that cross encoders re-rank documents. You get a 1 rating for detail because you just, said 3 words, and then you get a 5 overall rating. So then let's try with an incorrect answer. What do cross encoders do? They index data. Maybe you could use cross encoders to index data, but it's not really a typical practice to do it like that. And so in this case, you get 1 for faithfulness, 1 for detail, and 1 overall. And this is a general thing with DSPy. If you ever want to see the last inference that just went into your LLM, you can do .inspect history n equals 3. So we're going to inspect the history of our metric LLM to get another sense of what's happening with this, with the metric LLM. So we've done n equals 3 because remember that every time it's doing the metric, it's doing these 3 inferences of how detailed is the answer, how faithful is it, and then the overall rating. So here's what those prompts end up looking like. And again, these are uncompiled prompts. These are the prompts you get just right out of the DSPy programming model box. So the first one that we did is the assess question. So first you assess the quality of an answer to a question, then you give it some description of the inputs and the outputs, and then you pass in the current inference. So you're saying assess question, is the answer detailed? The assessed answer, they index data, and then this DSPy.chain of thought, the reasoning. Let's think step by step. In order to produce the assessment answer, we need to consider if the answer provides enough detail to fully answer the question, and then assessment answer 1. So then we see how we do this with the other ratings. So in this case, we're passing in the context as well, because the assessed question is the assessed text grounded in the context? Say no if it includes significant facts not in the context. And then again, the reasoning about how it's going to produce its metric. And then again with the overall rating. So hopefully that gives you a sense of what the metric LLM is doing. And again, you can always inspect the history. You can similarly inspect the history of the LLM that's doing the predictions by also accessing it like this. So, or this is because we didn't actually pass this through the RAG program. Okay, so let's skip ahead and let's get to the next section where we're going to be writing our DSPy program. Awesome, so now that we have our dataset's loaded into dspy.Example objects and our LLM metric, let's dive into the DSPy programming model. So again, we're going to be building a pretty simple RAG program where we just retrieve and then answer the question. So the first thing to note is to understand signatures and DSPy modules. So instead of using an explicitly written signature, we could also do something like question, context, answer, and DSPy will parse that into a signature. And I think this is a super interesting syntax for quickly sharing your DSPy programs. I imagine we'll probably see something like a DSPy gallery emerge, similar to kind of the story of LangChain. And as people are building out these LLM programs, I think this shorthand syntax is a really great way to quickly explain what you're trying to do with these programs. But when you do want a little more control, you can instead pass in the full signature to a DSPy module like this. So we have our DSPy signatures. Now this is where we give it the initial prompt, as well as some descriptions about our input and output fields, as well as in our input and output fields. Okay, so then we connect these components together in the DSPy module. So in this case, we just have a retrieval engine and a generate answer LLM. So this is pretty standard. You can imagine adding other layers. Like if we want to have a, like a re-ranker here, we would add this other predict and say, we had like question, context, re-ranked documents, or if we wanted to add summarization, like, summary, and then we want to call this our summary module, and then say this came after this. So we then said context now equals self.summary, question equals question, context equals context, and then dot summary, and then, say we then pass that into a prediction and so on. But so hopefully that gives you the sense of how you can add depth. So when we're saying add depth to our DSPy programs, what we mean is adding more prompts in the middle, more components in, say, our computation graph of the LLMs that transform text throughout many layers of processing. But in this case, we're keeping it pretty simple with just retrieve and then generate, because I really think it's more important to just, in my opinion, it's good to just have one LM to optimize in the beginning to see what the Bayesian signature optimizer with the Bootstrap Few Shot is doing. So, again, I think the goal of this video is to try to be like a CFAR 10 for DSPy and a simple example. But anyways, so this is how you connect the program. Let's have a little more of a look at these built-in modules. So if you want to just use your prompt out of the box without any of DSPy's built-in modules, you can just use .predict, and you'll see what are our cross encoders. And if we run that, okay, so you see how with predict, it just, answer questions based on the context, the initial description that you gave it in the signature, and then it answers the question accordingly. So this is what chain of thought is doing, and I am super fascinated by this. It adds this reasoning, let's think step by step in order to, and so let's think step by step in order to produce the answer. And you can also access this reasoning as a dot reasoning from the DSPy. So a pretty interesting thing. And then here's another module, dspy.React. So with React, it's that the tool use, the action kind of prompt. So in this case, you say you'll be given context question, you'll respond to the answer. To do this, you will interleave thought, action, and observation steps. So, now it's doing this thing of search, finish, answer. And so it's making these actions like action 1, finish, answer, thought 2. So I haven't dived in too much into this, but I hope this just gives you the quick preview of how you can instantly get more value out of your prompts just by using these built-in modules. And there are a few others as well, like multi-chain comparison or program of thought. So I haven't personally gone too deep into this, but I just wanted to, quickly make it aware in this video. Okay, so now we have connected our program. So again, we have built this RAG program as defined here, with our just retrieve answer chain of thought on this generate answer signature. And now we define the program by just uncompiled rag equals rag. And now we can pass a forward pass by saying, uncompiled rag, and then our input, what are re-rankers and search engines, and access our answer. And then again, I think we've already seen this a few times, but you can inspect the history like this. Okay, so now let's get into the fourth part. We're now going to be evaluating these programs and optimizing them. Okay, so now the moment that you've been waiting for. So first of all, thank you so much for making it this far in the video, or if you wanted to skip ahead to see the optimization, also welcome. Now we're going to be using the DSPy compiler teleprompters to optimize the prompts in the RAG program and achieve better performance according to our LLM metric. So as a quick reminder, again, we have our development set where we have these questions, and we're going to be evaluating our program on the development set, whereas we optimize them with the training set. So we're using the DSPy evaluate object. We construct it, we pass it in the development set, tell it the number of threads to be running the evaluation on, display the progress, and display the table at the end. Then we give it a newly initialized uncompiled RAG program, and we pass in our LLM metric. Okay, so we run this. Okay, so it's now running through the test set and evaluating the metric on each of the examples. So we have, we have 10 examples in our test set. So I think our maximum rating would be 40. I'm not sure. I think they're multiplying it by 10 here with 244, but So anyway, so we'll just say 244 is the score for our uncompiled RAG program. Okay, so we can see the history of our uncompiled RAG program without any optimization. It just has a description of the task, then it just, retrieves the context, and then it just has the question, does Weaviate use HNSW lib, and then answers the question. So then we can also, again, inspect the metric LLM whenever we want to, like this. And now let's step into optimization. So the first optimizer we're going to be using is Bootstrap Few Shot. So that's going to be looking to get examples to put in the prompt, and it's going to stop once it has, and once adding more examples to the prompt no longer increases the performance. Okay, so we run this, and so now it's doing its thing, optimizing the program, and I'm not super familiar with the details of Bootstrap Few Shot and all these things. I think this is something that we'll be continuing to explore in the video series, but I think the analogy here is with PyTorch and Keras. When we were training neural networks to classify cats or dogs, we had all these optimizers like Adam, Nesterov, and so it was, the abstraction was you weren't necessarily super interested in all the details of the optimizer, kind of. Some people, obviously, if you specialize it, that's your thing, but so I kind of think the abstraction is the same way here, where we have these different optimizers, and you might want to just kind of try which one works the best for you. In the end, from my experience, I don't want to tease the video too much. Maybe let me cut this and then come back when it's finished compiling. Okay, we're back, and we finished compiling the RAG program with Bootstrap Few Shot. So it runs through and it bootstraps 4 full traces or 4 passes through the program where it successfully or maximizes the metric with, say, 5 faithful, 5 detail, 5 overall, and now we're going to be using these in the prompt. So here's what so now we can just see an example of the new answer, and then we can see the history to see the prompt that it came up with. So we have our initial description of the task, and now what we have is examples in our prompt. So we have this example of looking at context, reasoning about the context, and then answering. And this particular example was determined to have a high rating with the LLM metric. Then we have another example that we add to our prompt, and then we have our current inferences where we're now asking the question, what do cross-encoders do? And we retrieve the context. And the idea is that by having these additional examples in the prompt, the LLM is better at now doing the current reasoning and the current answer. So now for the exciting thing, let's evaluate our compiled RAG and see if we've improved the metric. So I'm just as excited as anyone watching. Okay, so we're running through the metric. I might be getting rate limited a little bit because I just ran this offline, so we wouldn't have to wait again for that. But okay, there will be probably a little bit of cutting around as we're running these compilations, and I cut the video so you're not just watching it loading. So in the end, we've compiled our program by bootstrapping these few shot examples to put in the prompt. Then we reran the evaluation with the compiled RAG, and our metric increases from 220 to 274. So this means that, that composition of scores of faithfulness, detail overall has increased from 220 to 274. Okay, so now things are really getting exciting. Now we're using the Bootstrap Few Shot with random search. So what that means is we're going to be, say we have 8 examples of traces through our program that result in high scores in the LLM metric, but we only want to use 4 of them out of the 8 in the prompt. So now we're going to be randomly searching for the combination of those 8 examples that when used in the prompt result in the best performance for the system. So this is quite a long trace. It's quite a lot of optimization that it's doing here as it's searching through all these programs and evaluating the scores and so on. But in the end, we end up with now improving our metric up to, I think, either 288 or 300. We'll see in a second when we run it through the evaluation. But so now we see our new example, and we can see, inspecting the history, we see these. So these, input, outputs, context, reasoning, answer, these are determined to have the best performance for our system with the new compiler. So now let's run another one through the evaluation, and maybe again I'll have to cut it, and this is maybe the problem with doing notebook tutorials. Okay, so after evaluating our second compiled RAG program with the Bootstrap Few Shot with random search, we end up getting a score of 264, and I'm not sure what this is about. I think yes, I'm not sure why that is lower, but anyways, let's now dive into our third teleprompter compiler, the Bayesian signature optimizer. So this one is my favorite one because it's not only coming up with examples, it's also rewriting the task description and then choosing what's the optimally performing task description. So in this case also, we're now introducing a third LLM to the party. we already have our LLMs that are used in the RAG program, and now we have the LLM that's used in the metric, and now we also have an LLM that's used to rewrite the task descriptions. So after running this, and again, I'm now running it offline instead of running it live with the talking through the notebook, we end up rewriting the instructions to assess the context and answer the given questions that are predominantly about software usage, process optimization, and troubleshooting, focus on providing accurate information related to tech or software related queries. Again, we bootstrap the examples, so we combine this rewriting of the prompt with a new task description, and this time we evaluate it, we now get up to 290. So one more thing I'm running through now is we're taking the party to the test set. So we've been using the training set to tweak the prompt, test the examples, and then we reported performance in the development set to maybe play with these optimizers, and now we're going to test our programs on the held out test set. Okay, the moment we've all been waiting for, the results of our compiled program compared to the uncompiled program on the held out test set. So we get 271 with the uncompiled RAG model, then we get an improvement of 285 with Bootstrap FewShot, then 255 with Bootstrap FewShot with random search. So I think there was a bug in the way that I set that one up, but my favorite one, 345.71 with the Bayesian signature optimizers. Thank you so much for watching this tutorial on getting started with RAG and DSPy. There are 4 major parts to this tutorial: setting up the libraries and loading in your data set, configuring the LLM metrics, LLM programming with DSPy, and then optimization with the teleprompters. I hope this end-to-end notebook helps you better understand how to use DSPy, what the framework is trying to help you achieve, and I can't wait to see what people build with DSPy. For me personally, I think my interest is going now into adding more layers to RAG, such as adding multi-hop, re-ranking, maybe summarizing search results, all these exciting things to extend RAG further. But I'm also just so excited about, say, building chatbots with this, or writing blog posts, writing code. I think the sky's the limit with what kind of programs we can build with this DSPy model, thanks to kind of the flexibility of the abstraction. So please subscribe to the channel if you're interested in following along with the rest of this DSPy Explained series. I highly recommend joining the DSPy Discord, and if you have any issues with anything in the video, please feel free to leave it as a comment, or just want to share your thoughts generally, and I'll try to respond to all the comments. Thank you so much for watching this video.